Hello, so we're now going to have a look at some of the more tricky questions in the development section for exercise 3D, so sketching quadratics using factoring. With all of these questions, if you can't remember how to factorize or you can't bother factorizing, the quadratic formula is fine. I will not mark you down for using the quadratic formula instead. I've highlighted the questions I'm going to do, so let's start off with 7F. It says use factorizing to find the zeros of each function, then sketch it. So the first step we're going to do is factorize. So what we've got is f of x, which is, y, equals 8, take 2x, take x squared. I always prefer to have my x squared, then x, then 8, so that I can easily tell what's a, b, and c. So I'm going to rearrange this. So negative x squared, take 2x, plus 8. Because don't forget, each of these negatives belong with the actual term. So that negative x squared went there, the negative 2x went there, and this 8, well, it's a positive 8 because there's no negative out the front of it. I also hate having a negative outside of my x squared. Actually, no, we can cope with that. We can totally cope with that. So, negative 1 times positive 8 equals negative 1, yeah? What multiplies to give negative 1 that adds to give negative 2? Multiplies to give... negative 8, I should have said, not negative 1, obviously. Negative 8. And adds to give negative 2. So, negative 4 and positive 2? Negative 4 and positive 2. So we rewrite our f of x. We've got our negative x squared out the front. Take 4x plus 2x plus 8. Because we're doing this by grouping. So I'm going to start off by grouping the first two, and then I'm going to have a go at the second two. Negative x goes into both of those, so negative x squared divided by negative x is left over. Negative x from negative 4x, positive 4 is left over. And now let's have a look at the other two. Oh, sorry. Now let's have a look at these other two. Well, obviously 2 goes into both of those. X plus 4 times, that's very handy because x plus 4 appears in both. So I'm going to get x plus 4 outside of negative x plus 2, or another way to write the exact same thing is x plus 4 outside of 2 take x. Yep. Okay, now we've factorized, we can go back into our normal steps for sketching quadratics. What's the first one? Y-intercept. Let x equals 0. So for this one, it doesn't matter whether we do it to our 8 take 2x take x squared, or our negative x squared take 2x plus 8, or our x plus 4 2 take x. It doesn't matter which form you would do it in. So f of x equals negative 0 squared take 2 times 0 plus 8. You can tell very quickly that is just going to be 8. And even if we'd subbed it into the brackets, f of x equals 0 plus 4 times 2 takes 0, 4 times 2 is 8. Next step, x-intercept, let y equals 0. So this is where, if you hadn't been able to factorize it, you would have just gone straight to the quadratic formula for this step, but we did factorize it, so we know 0 equals x plus 4, 2 take x. You can probably tell straight away from looking at this what the x-intercepts are going to be. We know that x plus 4 equals 0, so x equals negative 4. You just change the sign of whatever's in the brackets. We know 2 take x equals 0, so 2 equals x, or x equals 2. Doesn't matter which way we write it. Again, well, you may not think of this as changing the sign of everything in the brackets, but it kind of is because that's a minus x, not minus 2, if that makes sense. Yep. Okay, next step. Axis of symmetry. Axis of symmetry. Axis of symmetry. Again, you could have just gone for x equals minus b over 2a, or you can do halfway between x-intercepts, which is what I'm going to do. So to find a number halfway, you add them together and divide by 2. So the x equals, we've got this minus 4 plus 2 divided by 2. It's negative 2 over 2. It's going to come out as negative 1. Oh, and if I could write that, it'd be even better. Negative 1. Okay. Our y-coordinate of our vertex is, we sub that in. F of x equals negative 1 plus 4. 2 take negative 1. Could have subbed it into the first version of the formula. 8 take 2 times negative 1 take, in brackets, negative 1 squared. I'd like to do it this way because then I have to be less careful with my negatives and less chance of me getting lost. Negative 1 plus 4 is positive 3. 2 take negative 1. Positive 3. 3 times 3 is 9. And now we can sketch. I'm going to sketch over here. Sketch. So I know that this graph is going to have to go all the way up to 9. I know it's going to have to go left to negative 4 and right to positive 2. They're my extremes. 4, 5, 6, 7, 8, 9. That'll do. That'll do, that'll do. These do not have to be perfect. Y and X. All right, let's put our intercepts in. So my y-intercept is positive 8. 1, 2, 3, 4, 5, 6, 7, 8. So that's my y-intercept. That's where it's going to cut through. My x-intercepts are negative 4 and positive 2. And in a different colour, I'm going to mark on my axis of symmetry, which is x equals minus 1. So it's going to be somewhere along this line. The y-coordinate of it is positive 9. So it's going to be here and it's going to go downwards. Oh, I forgot my very first step. Gosh, I forgot to find the concavity. You can actually survive without figuring out the concavity because it's kind of obvious once you start to draw it. But it's nice to have concavity. It's a sad face because minus x squared in the equation. So we know that it's going to be sad, which means it's going to go like that. Pretend that went, oh, that was terrible. I'm doing that again. We're going to go like that, and this one's going to go through that one and down there, and that's it. All right, let's now look at question 8b. Sketch these parabolas involving perfect squares. Begin by factorizing the quadratic. In each case, symmetry is needed. I actually wouldn't bother. Like, that's written much more difficultly than it is. With b, y equals minus 2x squared, minus x squared plus 2x plus 1.